Hello, civil engineering students. I want to give you a little bit more guidance here on this loads problems that you're working on the load assignment 3.2.2. I have here on the screen what's called a Dakin Helper, prepared by a colleague of mine to help you guide you through this lesson on loads. It's pretty complex in terms of where you have to go to find your answers. Just trust this guide here to sort of help you through designing a roof for a high school in Chicago, Illinois. So as you work through here, later on when you get to the truss table, you're going to need to know that the spans that you're crossing here and the girders and all, you'll need to know all these numbers eventually, okay, on the spans and the lengths. But if you will look both here and in Project Lead the Way, you will see you have several resources available in Project Lead the Way. Three or four of these refer to the IBC, a table or a figure in the IBC, which is the International Building Code. You will go to those tables in the PDF that I provided for you in Assignment 324. And you will look these tables and these figures up and get your answers out of that document. Okay. You also have an importance factor table. If you click on that link, it will open a table that will show you category 1, 2, 3, 4, depending on your importance factor of that building. And you will determine that in your case from the IBC. You'll know what your importance factor is, and from that you should be able then to look at the table here to get your IS number, your importance number. You have a weighted materials table, which shows you the weights of all the material used on roofing. You have a K-series, couple of K-series resources that allow you to decide which size joist you're actually going to use, and that'll be the subject of a separate video. This gets you to the point where you will know the roof load in pounds per square foot, and then I'll have another video on how to take the roof load and use the truss tables to pick a truss that you need. Okay, so this is just to get you to the roof load. So if you follow this guide here, you're using this formula here out of the PowerPoint to calculate a design snow load. Turns out these factors, the first three C's, are all going to be considered to be 1 in this problem. So they sort of just go away. So really, in order to calculate the snow load, PS, the design snow load, you only need to know the importance factor, I, and the ground snow load, PG. Well, again, the importance factor comes from, first of all, looking in the IBC to find the occupancy category. So that's IBC 1604.5 for high schools with more than 250 students. Find out whether we're class 1, 2, 3, or 4. Put that category here and here in these two blanks. Once you know it's a category 3, then you go to the table. You go to this table here in the loads assignment, and you click on the importance factor table, and it says for category 1, 2, 3, or 4 what the IS should be. So pick the proper IS from this. Okay. Then once you know that, you're going to go to IBC again, figure 1608.2, to find the ground snow load for Chicago. And I think I have that one pulled up already here. So this is actually table figure 1608.2. So I'm in the IBC, and you know Chicago is at the end of Lake Michigan here. It's right in this area. So its ground snow load is 25. And that's based on weather data. So now you're going to calculate this long formula in this blank space here. So it's going to be design snow load, PS, equals 0.7 times 1 times 1 times 1 times whatever importance factor you found out, times 25, which is the ground snow load. Now, you got one more check to do. Since the ground snow load was greater than 20, you have to, in the PowerPoint it explains this, you have to take the importance factor, whatever you calculated, times 20 in this line here. So importance factor times 20, and you get a number for that. And then whichever number is larger, the one from the long formula or the one from the short formula, you use the largest of those two numbers. So down here, you'll have your snow load calculated here for part 1, right? Now you go back to table 1607 in the IBC and you'll find out what is the live load for a low sloped roof and put it in here. It'll be in a table under low slope roof. Then you need to figure out the dead load of the building, which is the weight of the building itself and any other equipment that's attached. This time we're only looking at the roof. How much does the roof weigh? So here you're going to go to your weight of materials table, which were back over here in your resources, the weight of the material table here. And you can go down through this table and you can figure out the weight of everything that's going to be in this list that we just saw here. So then the Dakin Helper, you're going to look up built up roof, pounds per square foot. You've got 5 inches of rigid insulation, so you'll have to take the number in the table times 5. The steel roof deck, how much does it weigh? Pounds per square foot. The suspended ceiling, how much does it weigh? And you're assuming the MEP, which is mechanical, electrical, and plumbing, weighs 10. So you add up all of this and round it off, and that'll give you a dead load. So now you have a snow load, a live load, and a dead load. Now, depending on the part of the country and who you work for and the project, there's different combinations of how we put loads together. In this particular case, since we don't want to complicate it any further, we're simply going to get the total roof design load, we're going to take the dead load plus the snow load, and we're just going to ignore the live load right now, and basically it's usually smaller than the other two. So we're going to do, since it's Chicago, the snow load is going to be significant, right? So we're going to take the dead load plus the snow load, and that'll give us our total roof design load in pounds per square foot. So this video is to help you get this far, and then there'll be a second video how to pick up at step 5 and go use the K-tape.